Welcome back to the final video in our lab tutorial. For this last part, we're going to go over the analysis tools that we'll use for the labs. Specifically, we're going to analyze the experiment that we conducted in part 2. Once again, I'm just going to give you a big picture idea of how the labs go for collecting data, uploading it to a computer, analyzing it, and then eventually writing your report. First of all, let's consider the example like we did from part 2, where we took a video of our experiment. In this case, we would take our video and then upload it to a computer, either via cloud service or email or plugging your phone directly into the computer. Once you've got it on the computer, we can analyze it, analyze the motion using Tracker, and then we would copy the data into Excel or Google Sheets. For labs where we'll be using the Firefox app, we'll be collecting the sensor data and then uploading it either to a cloud or emailing it to ourselves and then getting it into Google Sheets. And then for the other kinds of labs where it's just collecting physical data from measurement tools, either from a measurement app on our phone or from the spring balance or a ruler, whatever like that. For those parts, we would just write it down and then copy it into a spreadsheet like Google Sheets or Excel. You could copy it directly into that, or you can write it down on paper and then copy it over later. Once we've got our data into a spreadsheet program, such as Google Sheets or Excel, we will copy the data over into graphical analysis. And this is just a graphing program that allows us to do curve fits and easy graphical manipulations of our data. Once we've finished the analysis and we've got our data in the spreadsheet program as graph pictures from graphical analysis and in pictures that we've taken of the setup along the way, the next part is to write the report, and you can do this either in Google Docs or in Word. For this tutorial, we'll be looking at Google's versions of these programs, specifically Google Docs, Google Sheets, and Google Drive, and I'm going to switch over and show you that now. Here I've got a window pulled up with my Google Drive account, and you can see that it's easy to organize things with folders. You can have your files directly there. Just like you would on a computer. So it's really like having a computer online. You can access it from any device. If you're not already familiar with cloud storage like Google Drive, I would encourage you to get familiar with it because it's very easy to transfer files from one device to another and be able to store them safely without worrying about them getting lost or erased. If you want to use Google Sheets, you can just click New and then Google Sheets. And that will open a new spreadsheet here, which you can type a title here. You can copy your data in and write all the formulas just like you would in Excel. The only difference is that it's saved continually, it's backed up, and you can collaborate easily with other people using the share option. If you want to use a Google Doc for your lab reports, the way you can do that, you can either create a new document and then click Google Docs here, and that will just create a new document like this. And it works pretty much just like a Word document. The only difference is that multiple people can work on it at the same time, and it continually saves it, so you never have to worry about losing your data. The other way you can create a Google Doc is to upload a Word document and then open it in Google Docs. So if I go down here and just open a file, and I'm going to upload this Word document. Now that that's up there, I can just open it, and you see it gives me this option to open with Google Docs. So if I do that, it opens this Word document as a Google Doc, but it's still sort of in the Word format. If I want to save it as a Google Doc instead, then I just go to File and then Save as Google Docs. But even as a Word document, I can still edit it. So let's add another line here. So you can see that's there like that. One other thing you can do here with Google Docs is download the file as different file formats. So if you go to File and then Download, you can click on Microsoft Word document. They've got some open document formats, some other ones here, PDF. So either Microsoft Word or PDF documents are good ones for uploading your finished lab journal to turn it in. The only caution I would give you is with PDF, if you do it with PDF, just check it over after you're done. Occasionally something weird happens and it loses part of the document. It doesn't save all of it. You might have a bunch of blank pages, or it might just save the first half of your document, something like that. So if you do it with PDF, it's fine, but just check it over, make sure that it has everything, and then if it doesn't, just save it again, and that'll be fine. And again, with Google Drive, just like any other file browser on your computer, you can delete documents if you want. So I can just click on this and then click delete with the keyboard, and you see that removes it as well. So that works the same way as a file system on your computer, and it's a handy way to do it, and you don't have to worry about saving it locally. Everything is backed up on the cloud, so you can access it from multiple devices. And last, if you want to use folders with Google Drive, again, you just go ahead and click New, and then you can add a folder, you can name it, and then put your files in it and organize them that way. Folders are very handy when you're uploading stuff all the time and you've got a lot of different files, especially for a class like this where you've got multiple labs and then lots of files for each lab. It'd be good to have a folder for each lab, and then you can just name them, dump your files in there, and keeps everything nice and organized. As you can see here, I've got the files that I uploaded earlier from my phone. I've got the acceleration data from the Firefox app, and I've got the video clip from the experiment that we conducted by rolling the ball. I'm going to download each one of those individually right now and show you how that works. So if we want to download an individual file, all we have to do is just right-click on that, and then go down here and click Download. Once that comes up, all you have to do is just save it where you like. I'm going to put mine in Documents for now, and I'll just go ahead and click Save. Before I do that, just notice that this is a zipped file. It's not a CSV file. It's a CSV file inside a zipped folder. So for those cases, you'll have to unzip it later, and I'll just show you real quick how to do that once I get it onto my computer. I'm going to do the same thing now for the video clip, and you can follow along and do this as well. The video will be provided to you, so you can do all the same analysis on the same clip that I'm using. Now that these are downloaded, I'm going to go ahead and open File Explorer. And if you've got a Mac or something else, this will be a little different for you, but the same idea applies. So in my documents, here's the acceleration file that we just downloaded. And again, this is a compressed folder, so in order to unzip it, I have to go here and either click Extract All, or I've already installed this other program called 7-Zip. So however you want to extract it, it's usually pretty easy to figure this out, and if you don't know how, just Google it and see, how do I extract files or something like that. So I'm just going to go ahead and Extract All. And this lets you decide where you're going to save it. So documents, that's fine. I'm just going to go ahead and click Extract. And now this gives me the CSV file that we recorded from the accelerometer data. If we were going to actually analyze this, then I would import this into Excel. But I'm not going to show you how to do that with this file because we'll get to do that with the Tracker program as well. Tracker will export as a CSV, and so we'll get to do it with that one instead. The next thing I'm going to show you how to do is analyze the video clip using Tracker. So if you've already got Tracker installed on your computer like we showed in part 1, then go ahead and open Tracker now. Here in Tracker, we're going to go ahead and click this Open File icon, and you can navigate through your files and find the video that we just looked at. Once that loads, we have the video open here in the main window. And as you can see, this video is horizontal, but if the video is vertical, we would need to rotate it first. So let me show you briefly how to do that, and then if you have any experiments where you take a vertical video, you'll know how to do that. So if you go up here to the top and click on Video, then you go down and Filters, New, and then there's a Rotate option. So if you click that, then you can just click, rotate it that way, or rotate it this way, or you can flip it upside down if you need to do that. I'm just going to go ahead and click None and cancel that because I don't need that filter right now. So the first step for our analysis is to calibrate the positions. So if you go up here to this icon, to the calibration tools, and just click New and Calibration Stick. So to do this, you can zoom in just by using the scroll wheel on your mouse, and then use Shift and click to click on the ends of your ruler. And then I'm just going to pan over here to the other side and Shift click on that side, and that gives me the length of the ruler. The default is going to be something other than the actual value, so you just need to change that. The length of this ruler is 0.305 meters. That's 30.5 centimeters. So just go ahead and click that, 0.305 m, and that one is now calibrated. The next step here, I'm just going to zoom back out. We want to add the coordinate axes. So if you go up here and click on this tool, looks like two pink lines. Just click that, and that places it on here. So you can choose your origin however you want. For this experiment, it's not really going to matter since it's not moving up and down, it's only moving left to right. I'm just going to go ahead and place it off here to the side, and it already looks pretty parallel to the ruler, so that's probably alright. So what we want to check now is just grab the slider and slide across your video and see where it is. So right now I can see that the ball is a little lower than that. So what I usually like to do is just grab the coordinate axes and place it so that the bottom of the object, in this case the ball, is resting on top of the horizontal axis. And then if you keep scrubbing over, you can see where it stops and see that it's still on there. If it's not, then you can rotate a little bit, so let's just check. And it looks like, let's see, let me go back and compare then to where that hit farther up. And scroll back over, so like see here, it's like right at the bottom. It's above the bottom edge of the shadow. So now if I go back over to this side where it went off the frame, I guess I gotta back it up just a little bit. Okay, so you see here, we want it to be level like that. So I'm just going to rotate this. You just grab the x-axis and you can rotate it like that. And I'll just bring it back up so that it matches with the bottom of the ball. That way the path of the ball is in a straight line. See? So as we go across the video, it always follows the x-axis. Okay, so let's take it back to the beginning of the video now. And I'm going to zoom back out. And what we want to do now is create a point mass. So you just go create and then point mass, and that creates a mass, and you can name it whatever you want. So if you want to change the name, you just right click on that, and then it's got name, so you can just click that, and I'll just name it ball. What we want to do now is just track the position of the ball. So I'll just scrub through until I find where the ball first comes into frame. And then you can use these buttons right here. This is step forward one frame and then step back one frame. So I'll just step forward, and now the middle of the ball has passed into frame. So all we have to do to track its position is just hold down Shift and then left click on the center of the ball or whatever position you're tracking. In the case of this ball, I would recommend using the center of the ball. It's easier to track than some of the other points on it. So I'll just go ahead and shift click right there, and we just keep going like that. Got the next step, and it'll just automatically advance to the next frame. So we just keep clicking until we get it all the way across and it's out of frame on the other side. As you can see, as it gets across here, it's kind of blurring in both directions. So it's got like a blur behind it and a blur in the middle. Usually what I like to do is just notice, you've got the solid edge here and the solid edge here, so just split the difference, and that gives you the center of your ball. Some objects it's a little harder to tell, but with a ball like this, it's pretty easy. And that, yeah, okay, there we go. So that's all it takes for tracking the positions. Now what we want to do is export the data. So we go down here to Table, and if you click on Table, then it gives you the options for what is shown in the table. We're not going to need Y in this case because the ball was not moving up and down. So we're just going to do X, VX, and let's just do AX as well. I don't know if we'll use that, but let's just select those three, and then you can click Close. And before we do anything else, let's save the file so we don't lose anything. And I'm just going to go ahead and save that. So you can click Save up here and save it wherever you like. I'm just going to leave it here in Documents where I've got the other things. You can put it in a more specific location if you want. Okay, so that just saved the tracker file. That did not save the data. So what we want to do to export the data now is come up here and click File, and then go down to hit Export, and then Data File. So what we want here, this first part, that's fine. Cells, all cells, that's what we want. Full precision, that's good. And then change the delimiter to comma. And then you can click Save As. And we'll just name it something like right now, let's say ball data. And then before you can hit save, you need to add the file extension on there. So we want a CSV file, so just click dot and then CSV, and that's all you need. And you can click save and then close that. And I'm going to show you one other thing that we can do with Tracker, and that is to save a view of this interface. So you can take a screenshot if you want, or what you can do is come back up here to File and then Export and Thumbnail Image. And you can either do the entire frame, and that will just do this entire window. You can adjust the resolution. I'm going to go up to the maximum there, and then PNG image is fine. So let's go ahead and click Save, and I'll just go ahead and save that. And then you can do it again if you want to see what the other ones look like. So thumbnail image, and the main view, that one is just this this window here with the video in it and the tracking marks and the axes on it. So if you want an image of just that, then go ahead and do that. You can click Save, and let's call that one thumbnail 2 and save. And see, now if I open this up, I've got this option, which is that, and then this was the main view. Yeah, this one was entire frame and then main view. See, that one just has the video with the coordinate axes and the tracking positions on it. If you did the third option, that would just be a thumbnail of the video, and it wouldn't have any tracking marks or other things on it, so that's not really as useful. So you probably won't need to do that. And that's it for Tracker. I'm just going to go ahead and click Save again so that we don't lose anything, and close that window. The next step is to import our data, our CSV file, from the computer into Google Sheets or Excel. And for this tutorial, I'm just going to be using Google Sheets. So if I go back to my drive here, I can open Google Sheets. And then we'll name this one, let's say, ball data. Then to import our CSV file, we just go up to File and then Import. And if you already have the CSV file in your Google Drive, you can just click on it here. Or if it's not there, then you'll have to upload it from a computer. So I'm just going to go ahead and open the File Explorer again, and then drag this file on top of that. Or you can just use the File Navigator and upload it that way. Okay, so we've got this, and some of these options, it's not going to matter as much. Let's just go ahead and insert new sheet. And separator, it looks like it detected automatically. Let's just see if it works that way. Otherwise, you can click comma, since this is a comma CSV file. And then that looks fine, so import data. And it looks like that worked well. So now we've got columns for time, position, velocity, and acceleration. If you haven't used Google Sheets before, but you are familiar with Excel, this works exactly the same way. It has all the same features. Some of them are a little different, but it really just works the same way. So let's just go ahead and generate a quick graph. We're going to do most of our graphing in graphical analysis, but we can also do some graphing in Google Sheets. So if you just select time and position columns, then you can go to Insert, and then Chart. And what we want is a scatter plot. So if you go to the column chart, change the chart type. Right now it's column chart. If you scroll down then you can find the scatter plot. So I'm just going to go ahead and click scatter plot. And now we've got a position versus time graph here. And if you want to add a trend line, that means just a straight line that goes through all of those points, you can go over to Customize, and then Series, and then scroll down here and you've got Trend Line. And normally this is only useful if you can also see the equation. So we also need to check Show or Use Equation. So label and then use equation. And that's the equation that we want. If we want to see the r-squared value, that's this. For some labs we may need that. I'm just going to leave it off for right now. So if you want to export an image of that, you can just click these three dots up in the top right corner and then click download, and you can download a PNG image or some other file types, but PNG is probably the most useful for what we're doing. So if I want to do that, I can just download, and then it already names it based on what your graph is. You can click save, and that would be a file that we can use in our lab report. If you want to customize your graph, make sure that your axes are all good. So you've got your time axis, your x-axis, well, x for position, the graph title. You can change all of that in the chart and axis titles. So here's the title text. I could change that if I wanted to. Let's maybe add on the word plot. And see that updated there. In order to change the horizontal and vertical axis titles, all you do is change the drop down on the right there where it says chart title and change that to horizontal axis title or vertical axis title, and you can adjust those as well. You can do all these same things in Excel if you choose to, but Google Sheets is pretty easy to do, and it's also really easy to import, or rather to export data from Google Sheets over to Graphical Analysis. And that's what we're going to do now. So what we want to do is, first of all, open Graphical Analysis. And while that's opening, I'm going to copy the data that we want to look at. So I'm going to exclude the top rows where we've got the labels, and then just copy the rest of this. So I'm going to do Control-C. If you've got a Mac, that's Command-C, or you can probably right-click and copy. There's one thing I forgot to mention earlier when I was recording this, and that is before you copy the data over to Graphical Analysis, you'll want to increase the number of significant figures on these data points. So right now we only have 3 significant figures, like we've got 1.67 or we've got 7.50. And if you copy it just like this, that's all it will have in Graphical Analysis. It will only have these 3 significant figures. So if you want to be most accurate, or at least more accurate than this, then you need to go up here and select this increase decimal places. And you just click that some number of times. You don't necessarily need to go all the way and include full precision, but you need to increase it some amount so that you get more accurate numbers when you copy over to Graphical Analysis. And unfortunately, I forgot to do that when I was recording this, so the rest of this analysis over there will not have these more accurate numbers, but these same ideas apply. So when you do this, just copy these after you have increased the number of significant figures. So in Graphical Analysis, we'll go to Manual Entry, and if you click this icon up here, you can switch the view, and I'm going to switch that to Table. And before we can paste our data in, we need to add some extra columns. Right now we've only got 2, and we'll need 4. So first of all, click the 3 dots on the first column, and click Column Options, and we can just rename our variable to time, T for time, and then units is seconds, and apply. Then our second column, column options, and this one is X, and units is meters. Then our next column, we're going to go and click the 3 dots again, but this time click Add Manual Column. The calculated columns are not very easy to use, so if you want to calculate something, just do it in Excel or Google Sheets before you copy it over. Then you can write your name for this, and let's just call this one V for velocity. If we had multiple velocities, we might want to have Vx and Vy. In this case, let's just put it as V. And this one will be meters per second. And apply. And one more column, add manual column. Call this A for acceleration. And units is meters per second squared. And apply. Now we just have to paste our data in, so we'll just click in the top left and then Control V or Command V, or you can right click and paste. And that's all we need to do for importing our data. Now we just have to graph it. So if we go back to the view options, we can click on one graph. If you want multiple graphs, you can click on those options as well. And here on the y-axis, we've got our position, and on the x-axis, we've got time. If we want to change position, we can have velocity or acceleration, or you can have all of them together. Let's leave it on position for right now. Let's look at some options now for modifying our graph. If we go down into the bottom left, there's this button here for Graph Tools. And you can add your graph legend. That's not really a big deal when you've only got one variable on there, but if you have two or more variables, then the legend is good. I'm going to leave that off for right now. Then the other one that we want to look at right now is Edit Graph Options. And this one allows you to put a title on your graph. So let's call this one maybe Position versus Time. And your appearance can either be points like we have right now, or you can just have a line, or you can have both the points and the line. Depending on what you want to do, I like either the points or the both option. When you're going to be putting on a curve fit, like a straight line fit, leave it as points. That way we can put our straight line through it and we don't have an extra line. It just kind of looks confusing. If you want to modify what part of your graph is visible, you can change your your left and your right range, and the same for your y. So the x-axis and the y-axis. I'm just going to leave that alone right now, but you can play around with that if you need to for whatever data you've got. And what we want to do now is look at the curve fits. So as you can see already, this one looks like a straight line. And so to do that with a curve fit, we just go down and click Apply Curve Fit. And now we've got a line that goes right through our data. And you can change it to other types of fits if you don't have a straight line. There's other ones. For these labs, mostly it'll just be linear, and then one of them is going to be sine or cosine. There might be other ones that you might want to do, but linear and sine are the two that we're going to use the most. So just click Apply, and as you can see here, it immediately adds the equation for the line. So we've got y equals mx plus b, and m and b are listed right here. And then the r value, that just tells you how linear it is, and the closer to 1 it is, then the more linear. So this one is very linear. What I want you to do now is just record this m value, the slope for our graph. Write that one down because the slope of a position versus time graph is going to be your velocity. So what we want to do right now is just record the slope as our velocity, and then we'll compare that to the average of the velocity from our velocity graph. So let's add a cell here for velocity and give that units of meters per second. And this will be from position and from velocity. So let's check back and see what that value was. It is 0.8903. So I'm just going to write that here, 0.8903. And then we're going to get the same value from velocity and see how that compares. Let's go back to graphical analysis now. And if we want to see velocity as well, let's add two graphs now. And this is velocity on this graph. So it doesn't exactly look constant, but it still fluctuates within a small range. We've got something very close to, looks like maybe around 0.9, between 0.85 and 0.9. So it's relatively constant, and it should be because the line is straight. If this line was not straight, then our velocity would not be constant. So let's see what the average of all of these velocity points is. So if you click down here on the graph options, we want to click on View Statistics. And this will give us our mean and standard deviation. Let's just use the mean for right now. If we want to use the standard deviation, that's available as well. So the mean is 0.891. So let's just copy that value over into Google Sheets. And that is, again, 0.891. And as we can see, that's pretty close to the value that we got from the position graph. And let's just go ahead and check how close they are. So for most of these labs, we'll be finding, comparing some experimental value to a known standard value, and that would be called a percent error. Or the other option is comparing two experimental values to each other that should be the same, and that would be a percent difference. And that is what we're doing for this lab. So we'll just write here percent diff. And the formula for that, either for percent difference or percent error, is just the absolute value of the difference of the two values divided by the one that you want to compare it to. So in the case of a percent error, where you're comparing something to a standard value, you would be dividing by the standard value. Like, say, if you were comparing it to the speed of light or the speed of sound, something like that, you would divide by the standard value. In the case of a percent difference, it doesn't matter which one you divide by. You can pick one. It just tells you whichever one you're comparing it to. So when we want to write an equation in Google Sheets or in Excel, we write a formula. And it's a little bit like writing code, like programming, but it's pretty simple. It's much more simpler than that. All we have to do is just start our formula with equals. So type the equals button on your keyboard, and then we write the rest of our formula. So we want the absolute value, and the formula for that is ABS, and then open parentheses. And then if you want to insert a number from somewhere on your spreadsheet, you just click on that cell. So we'll just click on this first one, and then minus, and click on the second one, and close parentheses. And then we just have to divide by the one that we're going to compare to. Let's compare it to the velocity, the average from our velocity graph. So just click that one, and then enter. And automatically this one is formatted as a decimal number. If we want to see it as a percent, then we just have to click on the percent button, and that changes it to a percent. If we want to add or subtract decimal places, we can do that. So we can change that, and it makes it 0.1, or increase it. We got 0.79. However you want to do that. Sometimes it's useful to change it. Let's leave it as 0.08 for right now. Now let's go back and look at our data in graphical analysis. So when we have a situation where the velocity is constant, as we can see here, the position graph is going linearly and the velocity graph is relatively constant, we would expect, if our object is not changing velocity, that the acceleration should be 0. And we can check this by going and adding a third graph and looking at acceleration. So we've got acceleration now on this y-axis and time again here. As we can see, the data is fluctuating around 0. So let's apply some statistics to this. If we go and add view statistics, that gives us our mean and standard deviation, just like we did with the velocity. And sometimes we'll have messy data at the start or the end of our data, and so we'll have to adjust the range that we're looking at, either for the statistics or for the curve fits. In this case, it looks pretty good, so we won't need to do that. Now, we would expect this to be 0. You can see now from the mean that it's not exactly, but it's pretty close, negative 0.309. It's a little off. Unfortunately, we can't use a percent error or a percent difference to compare something to 0. There are other ways of analyzing it, but we're not going to look at that in this lab. So let's just get rid of the acceleration graph right now. Let's switch it back to 2 graphs, and then we'll export an image of this data to include in your eJournal. Before we do that, let's add a title to the second graph here. So just go down to the graph options there, edit graph options, and let's change this one now to velocity versus time. And now we can export our data. So let's go up to the top. And if you wanted to save your file, you would do that here. So just save as, and let's just do that real quick. So we've got ball data. And then to save it as a picture, we want to go to export instead of save as. So export and graph image. Let's just call it GA plot for right now. So save that. And if we jump back over to the File Explorer, that should be here now. GA plot. And as you can see, we've got both graphs on here. If you wanted to do just a single graph, then you would have to change this back to one graph and then just export that single thing. In this case, just put this entire one into your eJournal, and then let's move on. One other thing you might consider is the size of the graph. For the one that we just exported, it created an image with the size of the window as we had it on our computer monitor. If we wanted to make it a little bit smaller, we could size it down like this and then export as a graph image. So I'll just do that again and show you what that looks like. Save and replace it. So now if we go back to here and open that, you'll see that it's smaller. So it's not the full screen anymore, it's like a more manageable size, but the labels still stay the same size. Sometimes that might be more useful. If you want to see more data, then maybe do it larger, but you still get all the same data, it just makes the labels easier to read. So sometimes that might be a better way to do it. Now let's go back to Google Sheets, and I'll show you how to do a mean and standard deviation in the spreadsheet. So let's go back to our main data here, and let's add a column here for mean, or a row rather, a mean and standard deviation. And if we wanted a mean, say, of our velocity, we would just type in equals average, that's another name for the mean, and then select the values that we want to average. And let's do the standard deviation. So that one would be equals STDEV. And then again, select the values that you want to do this on, and that gives you that value. And this is a good example to show how you can reduce the number of decimal places. So when you're selected on that cell, you can just decrease that and bring it back down to a more manageable number. Another thing that I could show you right here is changing the number format. So the mean right now is in scientific notation, and that's just because all of these are in scientific notation. If we wanted to change that, we can go up to Format, and then Number, and change that to number format. And again, you can maybe increase these, make them the same length. And let's do the same thing now for our acceleration. So equals mean, or rather average, and select our data. And then same thing for standard deviation, equals STDEV, and select the data. And that gives us those values. And you could do the same formatting on these. One way you might do it is copy these cells and then do a paste format only. And that just applied the same format to these cells, but it didn't change their values. See, these formulas are still the ones we just typed in right there. One last thing I need to show you in Google Sheets or in Excel is how to generate a calculated column. And to do this, we just type in a formula for one of the cells and then fill it down the column. So as an example, let's calculate the translational kinetic energy of the ball. There's also going to be a rotational kinetic energy, but let's just keep it simple for this example. The only variables that we need to calculate kinetic energy are the mass and the velocity of the object we are considering. So earlier I measured the mass at 62 grams, so that would be 0.062 kilograms. And so we make a column now for kinetic energy, we'll call that KE, and units of joules. So the formula for kinetic energy is 1/2 mv squared, where m is mass and v is velocity. So if we put in equals 0.5 times m, which was 0.062, and then we have times velocity squared. So we'll have times, and then we'll click on our velocity cell, the first one, and then squared. And we only have to do this now for one cell. So if we copy this cell down, we can do that by just grabbing this little square in the corner and then just dragging it down through all of the velocity cells. And it copies that same formula down. So now we can check here and it has the same thing. We've still got 1/2 mv squared. And it uses the new velocity value. So let's just change this now, get rid of the extra decimal places. And that would be kinetic energy for each one of those points. So anytime you need to calculate a column, you just have to type in the formula once, and then you just drag it down and fill it for all of the other cells that you need to do that for. And that's it for this tutorial. Go ahead and record anything that you need to in your eJournal, whether screenshots or data or tables. All of that is pretty easy to do in Google Sheets, in Google Docs, in all of that. If you use Word or Excel, that's also fine. For anything that you need help figuring out how to use Google Sheets or Docs, there's lots of help documents online, the same for Word and Excel. So if you need help with any of those, just go ahead and type searches for those. And that should be it. I wish you the best with all of your labs, and I hope you have fun with them, as well as learn something interesting that you can apply to the rest of your lives.